Hello, everybody. It's John here at Spoons Works. We're going to go over parallel circuit today, or in this vid, in the rules for parallel circuit, and then how to do an analysis on one. All right. So we know that DC means direct current, typically used in your car. AC means alternating current, typically used in the house. We're going to be dealing with DC when we're doing this. Series circuit is like the cheap Christmas lights. Parallel circuit's like the good Christmas lights. In series circuit, if the light burns out, the whole thing's out. Parallel circuit, light burns out, you know which one it is, you can replace it. Much easier. All right, so for rules of parallel circuit, you got voltage is constant. So E total equals E1 equals E2 equals E3 equals into E end, and it's for infinity. Current is additive. I total equals I1 plus I2 plus I3 plus I to the infinity. Mute out that computer there. All right, so and resistance is reciprocal, and I probably spelled that wrong, which is not the first time I've ever done that in my life. I think it's either an A or an O, and I never remember. Could have been an A. Oh well. So RT equals 1 over R1 plus 1 over R2 plus 1 over R3 plus 1 over R to the infinite number. Your total resistance in a parallel circuit or a parallel branch is less than the smallest resistor in that circuit or branch. Branch comes in handy later as a reference. Comes in handy later as a reference when we're dealing with combination circuits. Now, maybe it needs to be an A. All right. So I have an example circuit here. We're starting off with 10 amps as our total. Total can also be referred to as a source. So in some books, they'll probably call it, they could call this I source, your source current, but I usually use total. So like on my chart right here, I'm using total. Now, we start off with 10 amps as our total, 5 ohms, 2 ohms, and 4 ohms at each location. That's done in the chart. 10 amps, 5 ohms, 2 ohms, 4 ohms. Now, I pre-worked out the reciprocal formula because it takes some time to do it, and if I make a mistake, I don't want to have to go back and redo it multiple times, which I often do make mistakes. It happens. And if you're worried about making mistakes, just don't worry. You're going to make mistakes at one time or another, and you'll just have to figure your way out of it. Because being a craftsman is not everything going right every time. Being a craftsman or a tradesman, tradesperson, craftsperson, journey person is being able to fix things when it's going wrong. So mistakes happen. You just got to figure out how to get out of them. So in this case, it's R total equals 1 over 5 plus 1 over 2 plus 1 over 4. What I do for simplicity is I don't try to put it all in my calculator with parentheses because I want to have my work laid out for me. It makes it easier on me. It's my methodology. It is my system. And remember, anytime you're doing circuit analysis, you should have a system that you're working by. Something you can check as you go. It makes it easier until you get really gifted at it. And I've been doing this. Wow, I started taking classes on this back in the mid 90s. I still run my same methodology quite a bit. Because any other time I take shortcuts, I end up out of whack. Something goes wrong. So I follow my method. It always works for me. So it turns into 1 over 0.25 plus 0.5. 1 divided by 5 is 0.2. 1 divided by 2 is 0.5. 1 divided by 4 is 0.25. So then it's 1 over, add them up, 1 over 0.95. When I do it on a calculator, I end up with 1.0526 and a bunch of numbers after that. Since nothing's going to round up to get me above, nothing's going to round up, I just take these out. And I end up with R total equals 1.05. So I'm going to do R total, our answers indifferently. So 1.05 is our resistance. Total. Using Ohm's law, E equals I times R. We're going to multiply 10 times 1.05, which means we're just going to move that decimal over one spot. So it's going to be 10.5 volts. Then, since voltage is constant, the voltage or the voltage drop at the first resistor 10.5 volts, same as the second. Same at the third. So if I'm looking for current, so then if I'm looking for current, sorry, I had to think through something in my head there. I thought I made a math mistake. 10 point, so my I is going to equal, I is current, E divided by R. So it's going to be 10.5 divided by 5 for I1. I2 is going to be 10.5 divided by 2. I3 is going to be 10.5 divided by 4. And my handy dandy calculator. It's 2.1, but I'm going to do it anyhow. So it's going to be 2.1 amps for number one, for resistor 1. I did do that right. It's going to be 5.25 amps at resistor 2. It's going to be 2.63 amps. The answer came out as 2.625, but since I'm already using this many places, and since this is 5 or higher, I round up. So this becomes 2.63. 5 or higher for me, I round up. So it's 2.63 amps. If you add those back together, 2.1 plus 5.25 plus 2.63, you get 9.98 when you add them back up to check. And by rounding, that's a good spot, because it's a rounding variation to get you that tight, that throws you off, but you're so tight that it's good. And that should do it. That's how you work one out. Now, if you're going to do one that only has 2 resistors in it, so we're going to modify this. So it's 2 resistors. You can use another formula to find total resistance. In this one, it's R1 times R2 over R1 plus R2. And it can be R1 and R2 because of what we're doing here. If it was branch further into a combination circuit, you could use it. Doesn't have to only be R1 and R2. So it's 3 times 6 over 6, 3 plus 6, 6 plus 3, which is 18 over 9. It gives you a total of 2 ohms. So in this case, your R total will be 2 ohms. Your E total will be 5 volts. So you'd have 5 volts here, 5 volts here. So this would be 15. I'm sorry, this would be 1.67 amps. And 6 into 5 is 0.867 amps, right in that ballpark. No, I made a mistake. See, that's why doing math on the fly for me is not the thing to do. I like to have a little bit of time to look at it. So 5 divided by 6 equals 0.833. 0.833 amps. You see my error? What I did here is I divided instead of multiplying. So this actually needs to be 20 volts. 20 volts. And like I said, this gets everybody. Everybody makes mistakes at times. I just happen to do it here. Oh, this 5 ohms. So this is going to be 4 amps. And this is going to be so then that'll work out. So 20 divided by 5 gives you 4 amps. 20 divided by 6. R1 is 3 ohms. The way I did it. I was using old numbers. So 3 ohms is going to give you 6.33 amps. This is going to give you, see what happens when I walk out my methodology? I make mistakes. So this can be 3.67 amps. Add them together, that'll give you 10 amps. But that's what I'm saying about having a method to do everything in. I was trying to just freehand this, and I made errors by not having it written down the way I typically do it. But this is how this one works. R1 times R2 over R1 plus R2. So now that I totally goofed that one up, had to go back and redo it, and then redo it again because I made another error while I was at it. This is the final answers in the correct format. Yep, this happens. I think it happened. Oh, I know it happens to everybody. I've seen it happen to enough other people. That's why you always have to check your work, look at your work, and do an analysis of it to make sure that while you're doing it, you did the math correctly. And since I don't edit, this won't get edited out because this is about as real as it gets. Everybody have a good one.